let me know when you're ready.
Yeah, ready. Good.
All right, good afternoon everyone, good evening. I'll just grab everyone's attention. Thanks very much for everyone for attending. Thanks for your patience whilst we're setting up. This is our monthly meeting for AIW New South Wales, the May edition. Quite a strong attendance here in person, and we've got a few people online, so we're trying something a little bit different. A few people wanted to join, but for example, are interstate. It's an opportunity for them to participate. A lot of interest in this particular session, and I think it was two reasons. We've got some very good speakers. I think their mugshot photos probably attracted a lot of attention, and the topic, of course, is of interest to a lot of people. So the guys will be talking about external termination heights in external facades and external areas, integration of wall cladding and waterproofing membranes, and compatibility with renders and paint finish, and a few other things as well. As a very brief introduction to our speakers, we've got Danny Bernard of F&R Consulting. Danny's got some hands-on experience having worked at CBS Building for quite some time, and he's been a site engineer, worked in facades and probably focused a lot in facades during that time, and got into design engineering, again looking at facades and distressed buildings, remediation specifications, remediation designs. He's been involved in some high-profile projects that have had a lot of public attention, and his designs have had to go through numerous audits. So, very experienced in that area, licensed builder, DBPA registered. And we've got Geroge Dahrie from Noviion Engineering, he's the principal and owner of the business, of course. A few people involved in that team, civil engineering background, lots of experience in residential, Class 2, Class 1 type of remediation work, forensic investigations, does a lot of work with expert witness, so he's quite skilled and knowledgeable and a lot of practical experience. So very good speakers tonight, so we thank them for their preparation time. And there's been a fair bit of work behind the scenes for them to get organised for tonight. And also thank you for your ongoing support of the AIW New South Wales. Okay, just before I kick off, just to let you know, the proceedings will be the presentation. There'll be some time at the end for questions, and then a bit of an update from David Previty regarding what's happening from a national AIW perspective, and then we'll open the floor up for any general questions as well. So thank you again for coming. We'll hand over to the guys.
Thank you, George, for that intro. Talked us up a little bit more than needed. We'll start off. One of the main things that always gets talked about, what's our termination heights. It's always at the start of the jobs, always becomes a bit of a complicated issue with structures, set downs, and causes a bit of issue for structural engineers a lot of times. But it's important to consider it properly, because our wind termination will protect us against wind-driven rain and other issues. But one thing that doesn't get looked at, or it's not, I guess, that well known to our other waterproofing consultants, how we come up with the termination height. It's always in relation to wind speeds. But one of the things that we want to talk about, and I want to share with everyone, is what are some of the factors that affect our wind speeds for our sites, because a lot of times we get posed the question of why is our next door neighbour got a different termination height to us when we're right next to each other. So that's one of the common questions we get asked, and I'll just start. We'll go to our next slide. These are just brief introduction to topics. So as I said, I'll start off with termination height and affecting factors. Talk about a little bit our integration with the wall cladding and waterproofing, and then both George and I will talk about compatibility with membrane systems and other features that we look at in terms of facade. And then George will take over with his waterproofing balustrades fixtures. And finally, we'll both jump on and talk about why it's so important for facade engineers and waterproofing consultants to actually collaborate with the builders, developers, and structural engineers to get a great and final result. So next slide. Next, well, we'll start off, as I said, with the termination height and the technical. So, a couple of standards for wind speeds and determination. There's a difference between residential, so class 1 and 10, which falls under NCC volume 2, and there's NCC volume 1 for class 2 and 9. So for class 1 and 10, you don't have AS 4055. It's a lot more prescriptive. AS 1170.2, which is mainly wind actions cover, is what applies for class 2 to 9, which is also what's important for our, whenever we're doing any jobs that fall under the DVP Act. So some of the common factors will be obviously our region, where we are situated across Australia, whether it be Sydney, Wollongong. They're actually in the same category, but if you go further up north or further away from the coast, that plays a role. The building importance, we'll start one by one. Building importance, building orientation, our shape, our neighboring factors, terrain. There we go. So with the regions, one map's disappeared, but there should be a little map of Australia, but it's disappeared.
Sorry,
Just
go back.
That's right. What's depending on what all these numbers here show are what our base regional wind speeds are. Now, this is sometimes a bit misleading because, like for example, Sydney would fall under A2. Everyone's going to look at our 37 meters per second, or for our 100-year scenario or 50-year scenario, 39, 41, take that and move forward. That's only for our region. That's not normally enough to cover our site-specific ones. So that's only our basic factors, and it plays a role. That's our starting point, but it's not what will be our final determination. That will go back to that all-important table at the end of 4654, the external waterproofing code. That table at the end that tells us our little termination height, our class, building importance will play a role. So this is why certain, and it happens a lot, buildings side by side will have different termination heights. We've got, for example, if you've got a hospital, you design for a hospital, or you're designing for a small residential 3-story walk-up, it could be side by side. The hospital will end up with a much higher termination height because it has to account for much more severe weather conditions, so higher wind speeds. So that.
And just further to that, it's interpretive to the actual engineer. So sometimes if I'm doing a wind report and Danny will be doing one, we may get different figures because it's up to interpretation as to how we deem the importance level of a building, which is quite a large factor. So, and also other factors, you've got mixed use buildings, so some have hospitals down below, or a lot more newer projects now have buildings which are connecting shopping centres, and then you have residential above. So you can't really delineate that importance level when undertaking that assessment. So it's prior to, I guess, the design building practitioners act, people were just making those assumptions and just assuming, let's just do a 70 or 100 mil turn up. So, and this is essentially the basis of how we're getting to that.
So that's, as George said, because there's mixed use properties, it's also and development is making it a bit more complicated in the sense of that we're going to have more people in these developments for longer periods, more usage, so that also tends to push up the importance of all those developments. So we end up having to be more conservative with our designs. But as George said, it is interpretive, it's not very definitive. New Zealand's different case. They've got a bit more prescriptive text, but not in the same standard. So it's one page down in the standard. Building orientation plays also a big role. Everyone talks about that southerly wind always being an issue. But funny enough, it's the standards, and which is based on past experience, it's the westerly that tends to have highest wind speeds. The southerly is not as high. You'll see these factors are actually reduction factors. So the only one that's actually one is the westerly. So that's sorry. Too quick on that.
How often are these updated, or is this figures from?
So this
how
got
long ago?
this got updated in 2021, but these factors didn't change even from the previous standard revision, which was 2012.
Yeah, right.
Yeah, so it hasn't changed since then. So there's other things that have changed in the new standard, which are how you interpret shielding and the terrain category, which I'll touch on now. Shielding is pretty much what you look at, what's around your existing building as protective elements. So if you've got a neighbouring property that's taller, or even potentially trees, like or new developments, or that can come into play to help reduce our wind speeds and so on, so we're not assuming we're in a worst case scenario. Now what's interesting is this effect becomes a bigger issue on being in Sydney on the east coast. If you're doing anything that's waterfront, your eastern elevation is wide open to the water, you've got no protection to coping that gust of wind at its full force, and that tends to also carry with it some ocean spray. So it's a good combination for disaster if the building's not well protected. But it will take into account, for example, buildings that are taller in the region, and has to be buildings that are taller, and it actually covers a bigger radius. So we're normally talking anywhere to 20 times the height of the building. So when we consider the shielding, it's not just the immediate vicinity of the building. So if you're doing a 10-story building, which would be close to 30 to 40 meters, your radius that you can take into consideration is 600 meters. Although up to, actually there's an additional clause that goes all the way up to 60 times, so up to 3 and a bit kilometers. But having said that, that also reduces, in some cases, when you're in the eastern or waterfront properties, we don't have that, or you're at a bay, makes it that little bit worse because you don't have those additional levels of protection from shielding. Next. So what we talk about here with terrain categories is the actual slope of the ground. If we're in a valley, if we're on top of a crest, if we're up a hill, it also plays a role. So if we're anywhere near, so you could also potentially be not that well protected from other buildings, and might be doing a bigger development, but your terrain, you're in the bottom of you're in the middle of the valley, it will actually play in your favour, and you're a bit more protected. You're on the top of the hill, you've got sometimes an upward gust that gets formed, and that's fine enough to take into account or not fine enough, but it's considered in our standards. So again, these tend to be more, the taller your building, the worse the factors. So it's actually sometimes could help reduce and takes into account, the taller the height of the ground, if you're above ground and above the building, the worse it is, which makes sense. So that's why high rises cop a lot of wind, and that's shown a lot of illumination with those details. That's why you see curtain wall systems, because it's enclosed systems, rather than having it in balconies on level 40, 50. No one wants to deal with that water and the potential noise and etc. on those levels. And finally, the other thing to take into consideration is sometimes is the shape of the building, because that plays a role. So if you're in a very slender building, you've got different ratios. You've got your corners of your building tend to cop a bigger wind than the center of the building. And as you get closer towards your roof, also you get higher wind speeds. So as you get closer here, the wind naturally wants to push away, and the same thing on the top. So that's why we end up with what we call corner zones, where we've got higher wind speeds and wind loads. So this also gets taken into account with other elements on the facades, stud designs, cladding, there's additional loading. But with our termination heights with waterproofing, that gets played, that gets also incorporated. Now, this is where it gets tricky. We might only be subjected to this corner area, which is only for about 5 to 10 meters of the building, out of a 50-meter building, where we've got the higher wind speed. What do? We pick the higher termination height to suit, because you're not going to step the building up and down on the same level. So that's sometimes you might end up with 100 mil, requiring 100 mil termination here, and everywhere else 70. We'll nominate 100 mil typically just because of consistency. So that's another issue.
Across every level as well.
It's open to you can actually interpret it in a few ways. You can actually split classifications across levels or even across elevations, but this now comes down to coordination and the design with engineers and so on, with the structural engineers. Because if you're going to split across levels, they normally have a typical slab on the higher levels, or past your podium levels. Normally you've got the retail, potentially transfer slab on like level 2 or 3, and then it becomes a typical design. So this, if you try to create a separate split classification where you lower the termination height on the bottom half of the building and increase on the top half, the structural engineer needs to be aware of that. Potentially might mean folds in the slab or bigger steps or even halts if needed. But you can split your classification.
Just one question regarding the corner zones and the elevations in respect to the roof terminations in the same zones and concerning vortex there.
Yes.
And how does that all come together?
So, not with your roof, you've got a separate loading also. So this isn't shown here, but your roof is normally treated as its own separate element, so you have a different wind speed there, and you'll be consistent on it. So this is that, I guess, magical table everyone looks at and references, but we all know it's an interesting standards and appendix of the external waterproofing code. So depending on, has caused some conflict or a few ways of interpretation, whether you can interpolate between your different wind speeds whether you just go follow your AS 1170.2, but it's also referenced 4055, which is your residential code for class 1 and 10, all in the same table. And the classification is also based on the residential, but for our commercial builds, which are class 2 to 9, they fall under the same category. So what this finally looks at is our ultimate wind speed. In 4055, there's also another table which has the exact same information, but it's got an additional column for service wind speeds, which is, in layman terms, your daily issues. But it's funny enough more conservative than the ultimate scenario, if you correlate it, which is what where it causes sometimes some complication with what termination height you should follow and what you should reference. And then I'm sure there are quite a few people in this room who can talk about this in even more detail than I can. It's whether this table should be is actually just a guideline or actually needs to be followed to the T. That's also another issue with this table. But hopefully, the new upcoming revision is this gets all resolved, and maybe David could give us feedback on that later on. Maybe.
And just further to this, so prior to a couple of years ago, slabs and buildings were just designed without really much thought of this. We are seeing from the front end when we're designing buildings that the first step is to get a wind report undertaken on a building and to confirm what the wind classification is, and most importantly from a waterproofing perspective is the termination height. So that means you can determine the size of your slab step downs or hobs, and then also that will then form the basis of your construction type. Is it going to be flat slab, which isn't ideal, but also step downs and needing those falls with screeds. And also what we found also is that this, especially when buildings facing the water, it really affects, say, the eastern elevation, and how, from a structural point of view, are you going to step down those water-facing slabs at a greater level, which then creates issues with your structural slab. So understanding this as your first point is a very important element for the overall design of the building. And from a waterproofing perspective, especially consultants, having this information prior to your detailing, prior to your specification and advice is very important, which is something that's not always available, especially in a remedial space.
Is it acceptable to reach that height with an additional angle?
It is.
It is. Yeah,
Depending
so
on your consultant's advice, but yes. We will talk about that probably later in the slide.
Yeah.
Is there any other questions regarding just this?
any more questions before we move on, I guess, to the next? Yeah.
So, when you do the weak design calculations, you assume AS 1170.2 takes into account shielding multiplier for buildings next to it. But there are some structures where you have like a parapet or balustrade. And from my understanding, the design stamp doesn't take it into account, and I should just like nothing. Or sometimes you actually have this like external walkway, you walk in and you actually have this external door. So is there any discount on the vertical termination height for this area, so you just assume that it doesn't exist?
No, so this is where the standard is not very helpful in that sense. So if you've got overhead shielding from, if your entrance or doors might be set back, particularly say it could be entryways or balconies, could be set back 2-3 meters. That shielding doesn't actually get into accounted in the design.
Sorry, can I just clarify? What was the question? If there is a door,
But effectively set back.
you can't have a threshold You can't have an angle on the threshold, is that what you're saying?
No, he's asking if the winch design is that protection
If you've got a
from
2
the
metre
building.
overhang.
Say you've got an overhang or a balcony or an awning, whether that gets taken into account.
Gotcha.
And it doesn't actually take it into account at all. So it's all actually just looks at it as a whole elevation.
They should, yeah, because the flashing standard actually takes that into account. So you don't need to flash above windows if you have a
600
a horizontal projection
Correct.
on certain amounts. So technically they should.
Correct. So we could have a
You can do an individual modelling
yeah.
to activate that, but as you probably can appreciate, it'd be a lot of work for each individual opening.
But for as a standard as a whole, there's no actual provision for overhead or for projections or anything to provide shielding. So that might be another 10 years before that gets incorporated into the
This is
standards.
shielding of neighbouring properties, not so much what
Or,
shielding of...
or even your own entry. So that would need to get looked at individually on a project by project basis, or entry by entry basis. So but the standard on its own doesn't actually account for overhead protection from like protection from the rain. That's also in the waterproofing standard. Nowhere does it actually talk about it between the waterproofing or the wind standard. It's something that's overlooked. Because the standard for the wind just looks at it purely by what's hitting the building, whether it be on the door or the overhead. So, yeah.
Just when you're talking about factors affecting the design of this, you're talking about buildings, close to buildings, and you're talking about trees, etc. I totally understand it. Buildings are fairly static, where you've got trees that are really dynamic. You can have evergreen, you can have deciduous, but you can also have die-off of the trees. So once you design, with that in consideration, and then, if trees are removed for whatever reason or die off, then that's just changed your parameters, hasn't it?
Well, even having said that, plants or import trees could be are dynamic, but even on the way even the buildings have been dynamic. We've been seeing buildings pop up left, right, and centre, and some get demolished.
Yeah.
But it's at the time. But to the actual factors of the shielding, if you gain or lose one building, it doesn't change that much.
Okay.
But we're talking like less than point something of a meter per second change for an individual. So there needs to be a drastic change or potential redevelopment of an entire area to take that into account. But having said that, if you were to do wind design for example, Parramatta 30 years ago and what you're doing today would be completely different.
How do you deal with supply conditions in regional city, like we have on occasions, and build that in and factor that into your...
The standard applies the exact same factors. The only difference is you've got a different starting regional wind speed. So that's going back to that first slide where it dictates what region you're in. The standards will have a literal map of Australia that goes to if you're in this city, you're in this region, this category, and then you just follow that table, and that will give you your sort of initial regional wind speed if you're following the standard, which is basically again on some historic data. But yeah, and they'll tell you whether it's cyclonic or not.
Sam, do you have a question? Or
So
It wasn't a question, just some commentary for some of the questions. AS 4055, which Jamie mentioned, that's the most simplified version of working out your wind loads effectively. It does apply to your sort of single dwelling homes, but only if it's less than 6 metres. Otherwise you can't actually use it. You can use it on 70.2. RAM 7.2 is the next level of complexity, but it's still an approximation. But with the factors that they use, the multipliers, etc., the reduction factors, etc., they're conservative. So if you were ever in a situation where you needed to minimise, for some reason, the termination height below what AS 4654.2 says when it correlates to 1170.2, then when you actually do wind load tunnel modelling, you'll find it almost always will be lower than the approximation of 1170. It's been made conservative so that in nearly every case you're going to be on the safe side as opposed to the wrong side of things. But if you ever needed to, you could do the modelling and you'll find generally that you can get away with something worse.
I have one for you as well. Do you model in cyclonic areas to the cyclonic conditions which seem to be extending more these days than what they were, or do you model down to what the regional wind speeds are?
It's what's prescribed in the standards of the regional wind speed. But having said that, as Sam said, what's in here is actually fairly conservative. It does overestimate what's actually in reality, or what we've experienced. In some cases, we work out sometimes wind speeds that's higher than what Sydney had experienced in the last 50, 60 years, or not just Sydney, but could be other cyclonic areas that have experienced on record. So these standards are fairly conservative. So they've somewhat covered what's happening today. Whether they're going to still cover what's happening in the future, that's a different story, but that's why these do need to get visited and updated regularly, these standards.
Excuse me.
Yeah.
In your previous slide where you mentioned the heights of the terminations, before that you mentioned that the Australian standard does not cover the shape of the building, and you have to create your own wind tunnel report. A structural engineer has to create one. And as per the height of the building, what I understand that the wind tunnel wind load changes as per the height.
Correct.
And if you see your first slides, where the building perspective is given, if you see the balconies on the corners have different, even at that height, the intermediate balconies will have different wind load and the corner balconies will have different wind load. So the termination which you mentioned, how to consider that termination in those areas as per the height?
Yeah,
because it will vary.
Correct, that's what I touched on a bit earlier. So this is what I was saying, your corner zones will have higher wind speeds normally than on the same level than your intermediate, or what we can call our general zones. But from a coordination point of view and design point of view, you normally have to take your worst case scenarios and take out, because you don't want hobs and set down the faults on your slab to be inconsistent from area to area. The number of times we've had to visit a site because our termination height of a form worker couldn't get the fold or set down properly, and then we have to come up with another solution to reach our termination height. It's been an issue. But going from level to level, I think that also got answered. You can split classifications and terminations going up elevation, but it comes down ultimately to your engineer that's signing it off and whether they're going to accept that.
So in that case, we have to consider the worst condition, the highest wind load.
Yeah. But you can, as I mentioned, split classifications if you really want to, but it complicates things in terms of coordination, and it comes down to whether you have to do a bit of value engineering, whether it's worthwhile splitting those termination, and you have to also do a bit of a risk assessment, safety and design. I'll just move on quickly on to the next topic. This one's a little bit shorter, this is less complicated. This is more of a quantitative version. One of the things that as facade engineers we have to, I guess, make clear is the difference what our wall systems are doing compared to the waterproofing systems on the horizontal surfaces. key word you'll hear is weatherproof against waterproof. Weatherproof doesn't mean it's impenetrable to water, but some water could potentially go through, but the idea is to be able to manage it and lead it to an outlet. So it doesn't have to, so our wall, that's why walls and pitch roofs or tiled roofs tend to have cycling. Cyclings do, they're not, they're vapor barriers, but they're not waterproof membranes. You get different types of it's flexible, rigid cyclings, but in all cases, that condition still stands. That's why it starts to become more and more important. Once any water that's gotten behind our rain screen or cladding, but sits in front of our cycling, you can push it out through the flashings onto, it's normally pushed out onto a horizontal surface, and that surface is normally membrane. So that integration and that junction is critical to make sure it's detailed appropriately and coordinated well. Otherwise, it's not, we're going to start having potentially to rely on wall systems to be waterproof, which won't work, because most systems out there don't actually are not waterproof. Whether they tell you they're ventilated or sealed, none of them will provide you a waterproofing certification in that sense. One key factor to mention with that is up until NCC 2022, with the exception of that, every other prior wall type for class 2 to 9 was actually subject to a performance solution, whether it be your cable, even masonry, which has its own standard for class 2 to 9 from weatherproofing point of view, was actually subject to performance solution. Now, 2022 has some wall systems that are compliant, such as your AAC panels or masonry and metal claddings. They're covered, but
No, there's a big caveat on that.
yeah.
So it says it, but not really.
Yeah.
It depends on the number, the KPA, essentially, the pressures. Hebel is only tested up to a certain KPA, and the rest is a performance solution. There is a big misconception, especially in class 2 buildings, that if we use Hebel and masonry, everything's done. But it's not the case, because you also have windows and you have openings, which also need to be factored in and assessed.
I mean, according to they do factor in winter reading.
That's structurally.
That's structurally.
Yeah. We're talking about weatherproofing wise. So once, if you go into detail, they've done, CSI have done testing. If we're talking particularly for cable, they've done testing, but there is limitations to what they can achieve. So there's only so much wind-driven rain you can blast against it before it starts leaking. Once it'll still hold, but water could start leaking beforehand. So that's why, as George said, there is a caveat to it. And even though they've introduced in the new NCC some wall types that can be done, but there's again ambiguity whether you've got a junction between two compliant wall types DCC, whether they need to satisfy. So if you've got a masonry wall junctioning with a metal cladding, each one individually is suitable, but that junction's not covered under any standard. So it's still a bit of a grey area.
Because it was technically not flashed. If it was flashed like brickwork, it would be half.
It still has a flashing, but it's a polyurethane.
Air pressurization.
Which still have a flashing.
It still has a flashing.
If you look at the installation guide, that will still require a flashing. I know that a lot of buildings previously haven't been installed, but yeah, if you look at the installation guide, there should be essentially, because there's a cavity behind it, there is a flashing that's installed in line with the pressurization slots. Sorry.
So these are some interesting examples sometimes of conditions that we experience sometimes on some projects. For example, where you've got either your planter boxes in front of a internal wall or a wall that's going to, external wall. What do you do when you try to drain that cavity? Where does that water go? So sometimes you might see that planter box right up against the wall. That causes an issue because you can't drain those cavities, whether it be from potentially water that's gone in because the wall isn't waterproof, it's only weatherproof. So you've blocked its outlet, or whether you've got scenarios where you've got additional cladding over additional another skin of wall. So in this scenario, you've got potential like AFS, or could be any other, could be just concrete. You've got etc. And then there's a cladding over the top. We need to be able to. Yes, this is waterproof. Yes, we've achieved our termination heights here. We've achieved our termination heights here, and that's all protected. But where's that then water going to go? So we need to sometimes drain things through cavities inside the wall, gets pushed out through flashing, or alternatively there's overflows or drainage that are either concealed or there's falls that needs to be considered. So this is where waterproofing consultants, builders, PMs, and facade engineers need to work hand in hand to avoid scenarios where we've trapped water behind walls that no one would consider. And having said that, the water doesn't necessarily need to be also from wind-driven rain. It could form from condensation, which is not as much volume, but it is a potential issue. And then it does build up. These are other scenarios on the roofs. We've got overflows, but we've got claddings over our parapet. What's happened to our overflow? Where does it punch through? We've seen scenarios where it's punched through, but just drained behind the cladding. Not recommended. Or what happens in the junction with that cladding. So even though membrane is terminating and it's flash and cap on the top, what's happening here if this fails? What's our contingency if water starts creeping behind that cladding? Either ponding on the roof, or if it block drains over time. So those are details. So not as much volume, but we should consider drainage in our cladding and having it ventilated, or open at the bottom and flashed appropriately to leave for somewhere for that water to exit. Which is why I think things like cable, etc., you'll see even in the manuals they still have flashings regardless.
Yeah, I just meant that in the sense it wasn't drainage flashing, it was air pressurization. When you were flashing, then you're right.
Oh, you're talking about the wing holes?
Yeah,
yes,
exactly.
wing hole. Yeah.
But not in the drainage sense.
Yeah. So and then here's a couple of examples where potentially sometimes architects want the cladding to wrap around parapets. You can't get your flashing over the top. What do you do to terminate your membrane? What do you do? Pressure seals, regulars.
There's enough penetrations of the membrane there to be considered.
Yeah.
100%.
Would you warranty?
Well, that's half the problem from a waterproofing contractor's perspective. Is all of these fancy facade designs. We've got to figure out how to actually properly detail the way you're fixing it.
Correct.
To the substrate.
So,
Yeah, and another major issue that we see quite often is overflows located in poor positioning, and that's a whole coordination thing between the waterproofing consultant, facade, stormwater engineer. So you can see overflow directly over a perforated screen. So during heavy periods of rain, that overflow is going to activate, and then wind-driven rain is going to bring it back in. So a lot of coordination is involved with these types of projects, and essentially knowledge of those locations is very important, and not just ticking boxes.
Yeah, and as George mentioned, the other common issues, putting on roofs, surround the entire roof with planter boxes, whereas your overflow is going through a planter box. So try. I might have touched on something sensitive here.
Serious.
So this is where sometimes going back to termination is and of our membranes and compatibility of different systems and what needs to be done. A lot of times, a lot of builders and sometimes waterproofing contractors don't like cutting in regoliths, understandably so. It's painful, or sometimes doing pressure seal, architects don't like the view of it, so they try to cover it up with render and rely on that as a termination for the membrane. Not covered in the external waterproofing standard as a beam to satisfied method, but it is possible to do so, provided systems are compatible, and between whether it be the render or paint system that's overlapping our waterproof membrane. That's sometimes an issue using polyurethane. Not a lot of things like to stick to it, which is a bit of an issue. And another thing that needs to get considered is potential flexibility and movement of the different systems. So if your membrane's a bit more rigid, but your overlapping layer is flexible, not a problem. But if your coating, if your overlapping layer is a bit more rigid, not as flexible, but you use potentially something like not recommended, acrylic external lead, but which is a bit more flexible with movement, with the building movement, etc. You might end up with some delamination or cracking, and then we've got a whole heap of issues with failed waterproofing or issues. So that's why a lot of times you do, whenever dolly tests are strongly recommended to make sure adhesion's satisfied. This is an example where it's actually failed. Then the renders actually in the coatings come off before the membrane came off the substrate, so which is not a great scenario. So there's things that need to be considered.
Example, that's the membrane on the outside of the window.
No, that there is just the epoxy to bond the dolly.
Is it hard to do? Like, the render's got a pretty low, they're pretty low strength, right? So, like, what are you trying to achieve? What sort of operating are you trying to achieve?
So it's the ideal scenario. This is the ideal scenario is to actually achieve your. You need to know what your substrate is. So, for example, if we're dealing with concrete, you want to know what your potential tension capacity of the concrete is. So, which is normally quite low. So, the ideal scenario is that you pull it's bonded that well, you pull off a bit of concrete with it. If you're dealing with FC, it's a different scenario that you need to consider that as well. But you need to look at on the specific substrate. So you want to make sure whatever that maximum bond you can get between the membrane to the substrate, you achieve that same number.
Sorry, you can go back.
Sorry, mate.
In this case, if I'm not mistaken, you would have applied the waterproofing over the render.
No. So this is just a piece for the dolly.
Okay, but this case is applied over the render, right?
No, membrane.
What is the pre-surface?
You've got concrete, membrane, render over the top. And then this this strip of black is actually just the glue for the dolly.
What's come off on the end of the dolly there?
The render.
I think that's all.
But in general, in the new buildings, people do the waterproofing first, and then they do the rendering on top
Correct.
of that.
Yeah. So this is the
What
scenario.
in that scenario?
This is the scenario that we're talking about. This is exactly it. So we want the render to actually adhere to the membrane to actually seal it. Otherwise, what's terminating your membrane, what's preventing potential moisture getting from behind your membrane.
But that photo is showing that the render is what? Debonded.
Correct. So, correct. So the render debonded the membrane. So there's a water. So you've got your concrete substrate. You had a waterproofing membrane, and then your render. So if the render if the render split off the membrane, it's not adhered to it properly.
Why would you test the render? Oh, you're testing the bottom of the render for the membrane, right?
Yeah.
But the membrane to the substrate is okay. It's just the covering.
Yes.
Yeah.
So instances of this photograph here, all we can tell is that the membrane has got at least a 0.37 ampere bond to the substrate. At least that.
At least, but yeah. But what we want to make sure is that the render is also bonded to the membrane adequately to provide that seal.
So does the same percentage for the MPA apply to the render as well as the membrane? So the render sticking to the membrane, right? The MPA and above.
No, look, the 1 MPA above is recommended. Yeah, that's a structural give or take, but that's trying to recommend it. Now it comes down to the consultant's discretion at the time. If you say 0.99, whether you're going to accept that or not,
Yep.
whether that's sufficient. But the 1 MPA is normally what's the
It's good adhesion.
yeah.
It's working with your termination, compatibility with renders and paint finishes,
Correct.
not structural elements.
Correct. But that's a high MP, 1 MPA, because that's normally rough ballpark figure for your tension load, which is what the suction is for the concrete. Concrete's on a little bit, like 40 MPA concrete, which is what a lot of things are nowadays.
What is this standards? To what standards you have tested this? Like Australian standards or yes.
ASTM.
Yeah.
ASTM B4541. Like the BS acceptable pull-up initially. And you mentioned 0.37 is still not acceptable.
Yeah, as I said, that standard only covers. Sorry, as I was saying before, it comes down to the discretion of the consultant. But general practice in Australia has been covered to up to 1 MPA recommended, which is that maximum adhesion you're going to get, because that's you start pulling off before you start pulling off the concrete itself. Whether you want to accept that or not, will come down to up to the individual's consultant.
That standard is only a methodology or
Yeah.
tag. It's a standard.
Yeah.
It does not tell you that this is the number you need to achieve for it.
Yeah.
It just says when you test the bond thread, use this method.
Yeah, and
the
it outlines.
number it gives you will tell you whether we accept it or not. So it's got nothing to do with what that standard says that 0.25 is acceptable.
No, that just outlines. But that number comes down to the consultants to accept or reject.
In this case, to have your concrete, render it, and have a membrane over that whole system on top.
It's hard to aesthetically finish.
It's an aesthetic issue.
Yeah.
Big issue.
Yeah.
With that,
situation. If that render is not polymer modified, there's no way in the world it's going to stick to the membrane. So if they're not using a bond coat to affect adhesion onto the membrane, that system is deemed failed.
Correct. I don't disagree. In this scenario, it was meant to be bond coat, but because the systems haven't been tested together, we requested a dolly test to prove its adhesion. And
was that out of interest? Was that a wish to kill poly as put onto, or was it a
Looks like it was.
it was water based. It wasn't poly. Yeah.
It was only acrylic.
Sorry, well,
And not the same manufacturer either.
no, they're different manufacturers
The warranty process problem.
as well. So
I'm just intrigued, how the hell did they get the dolly to stick on the vertical? It's very hard to stick it on the vertical because it sags down. You use the glue.
yeah,
It's gonna, yeah.
look, that's beyond my expertise. That's move on. George has a
Sorry.
few.
I got a bit excited. What are you doing?
Great presentation.
Sorry.
Well done, George.
Yeah, just clear.
Yeah. Okay,
Sorry,
we're-
mate.
Yes.
We're going forward.
Alright, there we go.
I just got to be quite quick. That is taking all the time. This is an example of just a remedial expert witness project we were working on. So essentially, I know it's difficult to see, but this is a precast building sandstone facade at the front, and they're essentially nets that were installed for safety reasons. Next slide. So essentially what happened was the sandstone's been fixed on some blackjack waterproofing and not mechanically fixed, glued to the entire facade and spot fixed as well.
Well, why did they waterproof that?
So yeah, just for weatherproofing, I assume you can't get, so there was a concrete facade, so they tried to weatherproof the walls, which was another issue in itself. But they've applied this membrane, no render, no mechanical fixings. They've used a we would never recommend a bitumen-based membrane behind facade because it will bleed through. And they've used normal spot fixed glue. So this is 2 years or 3 years after construction. The owners first started noticing it within 6 months of it being constructed. So this is back in 2019. It was a four-year process to get here. Now, remediation-wise, obviously the builder didn't want to rip everything off. So if I go to the next slide, we did some pull-off tests to see how extensive the issue was, and pretty much all failed. So we then had to design some helifix ties to tie this a sandstone back into the wall, which then posed other issues with water ingress, possible water ingress issues, because you're then piercing the membrane behind there, right? And aesthetically, there was issues with them trying to colour match those holes, and also cracking in the sandstone. But I won't get into that too much. Next slide. Another example was in the same project. The contractor obviously had some drummy tiles there, but render was falling off throughout the parapets and external facade. They had used the same membrane on the upturns, so must have been a discount from one of the manufacturers, but they used it extensively throughout. And this is essentially what we're seeing. Danny touched on it before. acrylic renders have different expansion contraction properties to their substrate, and if it's not fully bonded, you're going to get delamination, you're going to get popping. Again, this is within 2 years of construction. So you saw the size of the building. It was quite a large remediation project. All the entire rooftop had to be replaced, the entire courtyard, all the external facade, sandstone. Yeah. Next slide. Just waterproof. So another, just a quirky one. Balustrade fixings and waterproofing detailing. Now, AS4654 is quite absent in how to detail waterproofing around balustrade fixings. There are obviously two main types of fixing balustrades. There's pin fixings, three pin fixings. So that's within the balustrade. There's connections, base plate, and then core holes. And there's different advantages from a structural point of view. Core holes are seen to be usually stronger, less maintenance. But just go to the next slide. Just one more for me. One more, sorry. So this is a core hole example. Typically what would happen is, what we've seen previously was contractors would be core holing and then waterproofing the core holes prior to the balustrade installation. Now that causes an issue from a structural point of view, because essentially you're then relying, your grout here should be fully bonded to this slab, because from a structural analysis point of view, you're not analysing just that one pocket, you're analysing the whole slab. Now when a membrane's applied, especially polyurethanes and non-binding membranes, you're then losing that connection, and then that causes instability of your balustrade. So we've seen that extensively when doing balustrade testing. Contractors are then waterproofing it, it's not adhering, and it's posing problems post-construction. Another large issue is people think grout is 100% waterproof, especially in balustrades. It's not the case. It's not tested. And if water gets in there, it's going to pond, it's going to cause long-term issues. So membrane should be applied to above.
To add to that water going in could also deteriorate the actual rail or the post that's within that's cast in, because you're in a moist environment that's actually holding, it's got nowhere to go.
What if you used like a bonding membrane, such as like a cementitious?
Right? So yes, you can. It's not tested.
It's not tested. Belts and braces under and over.
You can. Well, it's always been seen as belts and braces. You know, you do base and then the top, but we're not recommending it. No.
What about epoxy?
Core hole. Install your balustrade non-shrink grout and then membrane up, which we'll touch base. If I can just go back to the slides, previous one.
What about epoxy?
Epoxy grout.
Epoxy grout.
Yeah, so that isn't 100% waterproof. It's the manufacturers, from what we've seen, won't warrant it as a waterproof system. So this is just an example of a cementitious membrane being applied to a cantilevered balcony. These are pin fixed balustrades. So I'm sure there's some non-compliances, but don't worry about that. So this is a proprietary product. The balustrade contractor comes in, installs the pins. This then enables the contractor to detail his waterproofing appropriately, up the cavity, up the walls, achieve his termination heights, and then detail correctly around each penetration.
Just to add to this is a balustrade system with a channel. So that's the channel coming afterwards and sit over the top.
Yeah, so if you just click onto the next one. This is the next stage. Tiler will come in. These are still protected, the pins, so it enables the tiler to come in, do their work, and then following that, the balustrades, and then.
You haven't achieved your termination height up the pin.
But the pin.
By maintaining the thread.
Why would the termination height?
Don't you need to lap the membrane up the pin?
It is lap, but essentially, go back one more. There's no, as long as you're membraning that junction, there isn't an issue from my perspective.
So you can terminate as long as you membrane around the junction.
Yeah.
But keep in mind that pin fixing is also going to be concealed.
Okay.
It is fully concealed. So just go up. Next one. Yep. So essentially, these tubes get installed, and then there's a big ratchet that gets tightened. It's quite an ideal scenario. Sometimes these systems are more expensive than conventional, but as you can see, there's minimal damage to the waterproofing membrane.
What about if you've got a spigot like frameless glass?
Sorry?
Like a spigot or frameless glass?
So they're core hold.
Yeah, but where do you stop the waterproofing on the spigot?
So I'll just go to the next one, which is an example of, go to the next. So here's an example of using a sheet membrane with a core hold balustrade. So the membrane was laid first, core holes are left, and this is another issue as well, core holes are left exposed. There's possible water ingress issues, which isn't ideal in a remedial project, but these were custom made balustrades, the owners wanted it, so, and you couldn't get that type of fabrication. So core holes come in, it then enables your waterproofer to waterproof. Next slide. And then your balustrades get installed, grout filled, and then each individual post has membrane, and then it allows it to be welded on to the existing. And then those are then upturned. Go to the next one. You can see that. And it gets upturned onto the post. Now some contractors will also then grout fill inside the post to stop water tracking in the post, but
But there's no vertical height requirement of that upturn.
not really.
The whole waterproofing.
Now in the standard,
It's the finished form.
the standard doesn't say shall, but it's best practice to upturn it. Now, I wouldn't upturn it 150 because you don't want the membrane to be above the base plate. I'm sure your client doesn't either.
Sometimes you get very small base plates though that allow very small amount of upturn. So what would you say is a confident level of connection onto there? Like 5 mil? Probably not.
Yeah, no, probably 20 mil minimum. Everyone's got their own opinion on this, but realistically, the purpose of freeboard is in the event of a flooding event, and typically your balustrades are at the highest point on a hole. So the likelihood of water tracking that way, and also these membranes are fully sealed, so water shouldn't be able to track behind the membrane because the post is quite tall.
That's providing you've got a hole, but if you've got a flat run off floor,
But even if it's flat on, right, this is a fully adhered membrane to the post.
Yeah.
So there's no way in water.
Unless it's poor workmanship.
Poor workmanship. Some would say that need a fresh termination using volatile.
So you've got your own design issues going on between the designers here, by the sounds of it, based on
everyone argues with it.
yeah.
But essentially, if this is a fully bonded membrane to the post, there's no way water's going to track behind it.
You've got a non-compliant drain right there as well.
Drain?
At the back, strip drains on the top.
Because the idle thread just cast into the hole.
Yeah, this is the problem with remedial. I know there's probably plenty of issues, but yeah. Andrew.
I've done a billion balustrade with chrome jiggers.
Yeah.
And the quality of spigots that you buy these days, some of them Chinese fake or whatever rubbish.
Yeah.
And applying a liquid membrane onto chrome sometimes doesn't work. Sanding it back, it starts to rust.
Yeah.
Have you got anything else on that? Because there's a lot of termination on doing with chrome spigots. There's a lot of complaints of liquid membrane going over it.
Definitely speak to Parker or Sicker after this. They will. And sorry, Brad. Look, the etching primers are usually the go-to.
The metal as well, like some metals need to be blasted, like
That's right.
mechanically,
Yeah.
cleaning them or trying to mechanically abrade them isn't good enough.
And this is what we're essentially saying. There are preferred balustrades,
Yeah.
and sometimes, you know, architects don't want pin types. So just trying to be involved in the initial I guess, discussions and advising the clients on issues. I think spigots are being used less and less either, anyway, due to the new glass code, which is going to be another seminar, but yeah.
From a contractor's point of view, George would pay to put the product down, not to design the building.
Exactly.
And that's the problem we have.
I think collaborating with your waterproofing consultant and definitely the manufacturers in understanding that, but that's a very good point, Andrew. It comes up a lot with compatibility. Next one. This will be the last section. I know everyone's going to go. But essentially, the delineation between facade consultants or engineers and waterproofing consultants, and where that line, very blurred line, stops. You know, vertically and horizontally, that's where it delineates. You know, he's a facade engineer and he's the waterproofing consultant. But I wish it was that easy. This is just an example of a section that, you know, as a facade and waterproofing consultant, you typically entail in new build. One issue is, and I'll touch on this very quickly, is freeboard heights and where they should be measured from. Now the standard says finished floor level, but in cases where you have a pavers on pedestal, where does your freeboard start and finish? So technically it's up here. If you want to take it down here, it's a performance solution. That's my opinion. I know a lot of people won't agree, but that's another scenario. But more importantly, it's more about how to detail your waterproofing membrane in junctions, which Danny spoke about previously. How do we drain the cavity, and how to terminate your membrane to enable cavity drainage while still maintaining your freeboard. So, for example, you're trying to drain your cavity here, but people would typically waterproof up this junction. That then doesn't allow condensation to drain. So then this is why the membrane has been taken behind this wall, and angle's been used to enable your freeboard height to be appropriately achieved. Just next one. Some more examples of, you know, pavers on pedestals, which are essentially being used on 80 to 90% of all new buildings that we're seeing at the moment. And, you know, where to locate your freeboard, where to locate your weep holes. Should they be up here and then upturn your membrane? The use of angles, again, behind, and then incorporating your sarking and how that will allow your cavity to drain, and then also still achieve your freeboard height as well. I think that's pretty much it.
Sorry, just with the internal angles.
Yeah.
There's been some confusion, like which way to run it. The leg, inside or outside, or it doesn't matter?
Look, you know, we've been in audits where, you know, people will say, but the standard says to do the dog leg like this. In my perspective, it doesn't matter. It's essentially the consultant's advice and how he interprets the standard and what's best practice. There's no one-fits-all scenario. You know, your water stop angle, you know, if it was straight hob, you could sit it that way or that way. The main perspective is understanding your freeboard height.
Other things to consider, whilst you can orientate it both ways, but remember that all termination angles, doors or windows, need to be boxed. So when you come to the returns, are you removing some bricks and putting your leg which you want to turn into your room, into the cavity as well?
No, I'm just talking about in front of the door, basically. But not into the cavity.
Yeah, but you get my point.
Yeah.
As soon as you've got to put a termination angle in, you also have to have on the reveal, at the fenestration, on the reveals, it needs to turn back out to the outside. And that needs to form a continuous tray. And so if your angle, if your horizontal leg is turned to the dry side of the structure, as in inside the unit or house or whatever, then you potentially have a problem. It becomes more difficult.
They're not lapping the bottom leg.
Well, and it's got an angle, it's got a horizontal that's projecting into the wall now, right? So it can be done, it's just...
Detailing wise, it's a difficult scenario.
The last thing.
So this is just a small extract from the Design Building Practitioners Act, which the handbook, which essentially dictates the requirements as facade engineers, what we need to do, and who we need to collaborate with, and what we need to ensure to produce essentially a performance solution for each individual building. So looking at overflows, looking at waterproofing compliance, looking at wall types, looking at sarking, windows, all those elements need to be looked at. And you know, the list is quite extensive, and that means we have to collaborate with each individual party, and that's a requirement under the new Act. So I could be here for another 2 hours to discuss that, but I probably won't. Was there any other particular questions?
I have a question.
Yes.
Definition of freeboard to protect against wind-driven rain.
Yeah.
Is that mainly across thresholds, or does it continue across into the cavity?
It continues across wall tops.
Okay. So just let me understand this. So when you go to a lot of projects, you see the termination angle for a subsill across an opening.
Yeah.
To determine the freeboard from finish to the top of the angle.
Yeah.
That's across the threshold.
Yeah.
But they don't take that across into the cavity.
Should be.
So but that angle, sorry, the purpose of that angle is to lower your hob at that height.
Yeah.
So, for instance, say you're doing a Hebel wall, right?
Yeah.
You should have a hob behind it.
So there's a hob at the threshold, and the hob continues all the way around the perimeter. Then the wall comes down. But normally, you see the membrane coming up to the angle across the threshold.
Yeah.
And then, what do you do in the cavity? Membrane the bottom track.
So assuming you have 100 mils freeboard height, right?
Yeah.
And you have 100 mil fold in your balcony, right? Your membrane will be terminated to that upturn on the fold, but you still require an angle behind the door according to AS 465.
At the door.
Yes.
And then when you go into the cavity?
If you've reached your freeboard height in the fold, you don't need to put an angle. The purpose of the angle is to...
Okay, but then you take it off the finished floor level, right?
Correct. Yes.
What if you have
tile system?
If you can't achieve the upturn like around the frame of the building, you generally go like 100 mil FC sheet.
FC sheet.
Install it and membrane up to it.
behind the Hebel.
Yeah.
When you look at the standards, where does it say it continues in through to the cavity? It just shows a cross section through the doorway.
Yeah, that's right.
That's what it shows in the diagram, but the wording in the standard is talking about having an upturn height at a transition between internal and external space. So everyone thinks doorways, because that's where, if you have that upturn, you'll trip over it, right? No one thinks about
That's what you
walls
see.
because it's not an accessibility. Yeah.
So when you go internal, external space, that even includes slab edges that are exposed under a subsill, and
if you don't have a horizontal projection,
yeah,
in my perspective, it doesn't apply. But some people believe it does.
That the wording of standards is going to be a little bit better, because in reality, if you were to really scrutinise the standard, it says that determination height is required where, the determination height needs to be sufficiently high to stop water from traversing where you're preventing water entry into the building. So hypothetically, using that wording, you've got a parapet capping, a hob around a balcony. The perimeter hob is not preventing water from coming into the building. One could argue, and it has been argued in court, that it does not apply to that particular location. But that goes against the general intent of, like, if you want to play wordsmith, you can in court, but it goes against the intent of the design.
but as a builder, best practice is to just continue it all the way around, without trying to argue and prove otherwise.
But I suppose, can I just extend on what you're asking? I think I might have interpreted it a little bit differently. If you're trying to achieve 150 mil, but you've got a 100 mil hole, does he need? Would we be required to put a 50 mil angle all the way across, not just the threshold, even behind the heaver wall?
Even behind the
Yep. And the membrane should extend up that, and then the heaver wall built in front. There's no detailing to the front of that heaver wall,
Definitely not.
so let the water drain out.
I just want before
I just want to add that because normally the normal drainage is designed for one in 20 years events. When we have 1 in 100 year events, we're expecting the balcony to form. And if you don't have termination up behind the wall, the water will go in. That's why we as a facade engineer always advocate to have termination height at least on the stud frame, so that to prevent, in case if the balcony point engage overflow, the water doesn't go into your internal area.
Yeah, so going off what he said, an angle around, not just considering the door.
It's poor practice to rely on it. Like, it's not poor practice, but ideally you should be folding down your slab to the freeboard height, which is what we touched on previously.
Yeah.
The wind report at the beginning of a project, inception, is very important.
Yeah, well, we're trying to find a good balance, because if you fold down the slab too much, you've then got problems downstairs of getting head clearance and other issues. But essentially what I'm trying to say, let's hypothetically say you were relying on the angle behind the door. Can you negate the angle around the perimeter of the building, because you know you've got a floor track there, and waterproof up the concrete and then continue up the steel
You
floor
can't
track?
waterproof onto the track.
But the other issue you have finding waterproofing on base track is it's normally packed. Because how level is your concrete? So you're going to end up having...
To be fair, we're being asked to do that.
And then also...
to sit there and walk between the track
and also
it's not ideal.
Yeah.
I said we have actually been asked to do that previously, but you go through boxes of mastic and it's far from ideal.
The other solution that can be done, you could introduce a hob just underneath your stars, so you don't change your fold, but you've got to step up at your thing. It's a bit hard. It's hard to form, but that's why the other solution is I was mentioned is FC strip that gets sealed, goes down from the lower end of the concrete up to your or past your termination.
That's mechanically fixed.
That's mechanically fixed. And then waterproof out. That's probably the most consistent and cost-effective way, and potentially dummy-proof.
George, David, this is a really robust conversation. It's engaged a lot of people here, and it needs more of this, I think, than what we're given tonight. And looking forward into the future, this will be a good topic to continue on with, I think. Agree.
We want George.
No, Danny can do the next one.
Just some questions online, guys. So the table of our upturn heights in 4654, is it acceptable to interpolate between the
It's a question mark. My personal view is I don't interpolate. I treat it as a tiered system. It's because normally in other standards or like I said, normally state that you can interpolate the tables. So from a conservative point of view, we tier our category, but it's left to the consultant's interpretation.
Discretion.
Yeah.
Add something to that. Stay tuned, that will be clarified in the next edition of the standard.
Sorry?
I said stay tuned,
Yep.
that will be clarified in the next edition of the standard.
Okay.
We've saved a lot of arguments.
Yeah.
When's that happening?
Next year.
That's next year.
What's happening? When's it coming out? Next year.
Yeah.
Just one more one. This is a pretty broad one, so however you feel like answering it. But how do you adjust for climate change? Account for climate change. Is there any of that at all in what you look at?
So I guess with each standard, the wind pressure will be updated to reflect climate change, or climate, as in negative, positive, whatever which way. That's why standards get updated every 5, 10, 20 years. So they're especially the wind standard, it's based on previous stuff, and that's what allows us to interpolate the next standard. And it just came out in 2021, so there won't be an update for at least 5 to 10 years.
And just to add on to that, that standard is somewhat conservative, so if it is getting a bit more onerous conditions in the near future.
Just for an example, if you're doing wind tunneling testing, like Sam touched on before, versus AS 1170, you're going from like an N4 down to an N3, just to put it into perspective. So you're probably saving 20 mil, 3 mil height. But you know, tunnel testing takes probably a year, costs 100 grand. So it's not used unless the building is quite considerable in size. So anything over 20 stories, 40 stories, sorry, or thereabouts. And also, just quickly, that standard is only applicable to 20. How many levels? 20 stories, 200 meters.
It's up to 52 meters.
Yeah.
But then there's a clause in there that takes into account dynamic factors of the building swaying, etc. But it gets a bit more complicated to analyze. So this is where high rises, it's strongly recommended to go to wind tunneling.
Cool. Any other questions?
Specify poly around what each story. Yeah, it's too many.
Your neighbours will get some free waterproofing. All right.
Okay.
Thanks, everyone.
Thanks everyone. Okay. Thanks guys, I hope you enjoyed all of that. Just probably a couple of minutes just to give you all an update on general things AIW related. Before I forget to member, those of you who will consider prospective members in the audience, if you've got value out of it, that's the QR code there to scan and sign up on the website, which leads me into, we've actually done a big sort of overhaul of the back end of the website when membership happens, so everything should be a lot more streamlined now. You log in, put your email in, make a bit of an account, choose your membership, pay it, and then you can also create your listing on the website for directory purposes and whatnot. So that's probably one of the big changes. There is still stuff happening at a national level. Technical committee is working on standards and NCC updates. Also making a bit of traction now, developing technical bulletins. You probably saw one come out a little while ago talking about wet film thickness, dry film thickness, the relationship between the two, aiming to have a lot more of those coming out in the coming months. Then, as well as the activity we've got here, Queensland and Victoria also very active in their own right, so everything's going really well. Trying to keep it short and sweet so everyone can get out of here. I think that's all from me today. George, did you have
just one final thing. Next month we're going to be not here, so we were alternating every second month trying to get a member manufacturer involved with providing some trainings and information and some practical hands-on. So
So next week we'll be at FOSROC, next month I should say, for June. And details will come out through the usual channels in terms of social and email notifications, so stay tuned for next month's. That's it, thanks for